Hey, Squeaks. What's wrong? You doing okay? Oh, you're bored. Have you tried playing outside today? Too cold, huh? How about doing a puzzle or reading a good book? Have you thought about calling a friend? Maybe you could catch up with Bill and Webb. You've really thought about everything. Hey, here's an idea. Why don't we do some experiments? I know you and Jesse have done a lot of experiments in the fort before. So why don't you show me how some of them work? I bet you're a pro by now. Why don't you join us? Maybe you can even do some of these experiments at home. Could we start with the blubber experiment that you and Jesse did? That one always looked like a lot of fun. Cool. I'm ready when you are.
When the weather gets chilly, what do you do to keep warm? Do you put on a sweater or slippers? Or maybe you bundle up with your favorite blanket? Well, if you were an animal living way up near the North Pole or down south in Antarctica, you wouldn't have those things to keep you warm. But then again, you wouldn't need them. Recently, we learned how reindeer and caribou stay warm, even though they live in the cold weather of the tundra. But what about animals that spend most of their time in icy cold water? These animals have a special adaptation that they use to keep warm. It's called blubber. Blubber is a special kind of fat that some animals have right below their skin. This layer of fat helps keep their body heat in and the cold out. Animals like seals, whales, and walruses all have blubber. It allows them to live in some of the coldest waters on the planet. So, do you think blubber would keep you warm? Would you like to find out? Well, Squeaks and I aren't seals or walruses, so we don't have any blubber handy. But we can do an experiment with something that's a little bit like blubber. Shortening, which is also known as cooking fat. Shortening is a kind of fat, much like blubber is, so we can use it to see if it'll keep me, or at least my hand, warm, even when it's dunked in ice cold water. So I'm going to leave one hand just the way it is and cover the other with shortening. Then I'll put both of my hands in ice water to see what happens. What do you think will happen, Squeaks? I think you're right. I think my bare hand will get really cold and that my hand covered in shortening will stay warm. If you'd like to join us in our experiment, here are a few things you'll need. You'll need 2 large bowls, some water and ice, plus 2 plastic bags large enough for your hands to fit in. And of course you'll need some shortening, as well as a big spoon, a towel, and as always, help from a grown-up. Also, make sure to do your experiment in a place where it's okay to make a mess. First, let's fill the bowl with water, which we've already done, and add some ice to make it nice and cold. While our water cools down, we're going to fill one of our plastic bags with shortening. You'll want to fill your bag about halfway full. Next, we'll put a second bag inside the one filled with shortening. That way, you can put your hand in there without getting shortening all over it. Now that we have the second bag inside, let's flatten them together and squish the shortening around so there's an even layer all around it. All right, we did it! Are you ready to see if blubber can keep your hand warm now? So we'll have one hand in our blubber bag and we'll leave the other hand bare. Now put both of your hands in the water at the same time and let's see what happens. Wow, how does that feel? Is one hand cooler than the other? My bare hand is definitely colder than the hand that's covered in shortening. So what's happening? The shortening is acting like blubber. It's making a layer between the cold water and my hand. And that layer keeps the heat from my hand in the bag to keep me warm. That's a lot like how blubber keeps animals warm when they're swimming in cold water. Their special layer of fat helps keep their body heat inside their bodies to protect them from the extreme cold of icy water. So now that we know how blubber works, Squeaks and I are going to cuddle up under a warm blanket and read more about animals that live in cold places. And maybe we'll find out some more fun facts and share them with you.
That one was so fun. I can't believe how much our blubber kept my hand warm. What should we do next, Squeaks? Oh, balloon rockets. That's a great idea. Could you show me how to do that one?
It might look like we're having a party, but we're actually conducting an experiment. Squeaks and I are experimenting with balloons to see what happens when we try different things with them, like blowing them up and then letting them go. Want to join us? Before we get started, let's think ahead. Other than balloons, what do you think we'll need? That's right, air. I used air to blow up all of these balloons around me, just like I'll use air to blow up this balloon. There! Ta-da! Even though we can't see the air around us that we breathe, it takes up space. And when we put air inside of something, like this balloon, it takes the shape of whatever container is holding it. Now, once I blow up a balloon, what do you think will happen if I let go of it and let the air out? Will its shape change? Will it drop to the ground? Or will something else happen? There's only one way to find out. You ready, Squeaks? Okay. 1, 2, 3, let go! So, what happened to the balloon? It flew out of my hand, zipped around a little bit before falling to the ground. And how does it look now? Letting the air out definitely changed its shape. But did you notice what happened right after I let it go? It didn't head straight for the ground. It flew up and around before finally falling down. That's because the air rushing out of the balloon from the bottom forced it to move through the air in the opposite direction. So, if letting go of a full balloon makes it fly around the room, what would happen if the balloon were attached to something? Let's see how we can use balloon power to make a rocket. All you need is some string, a straw, some tape, and a balloon. And maybe a friend or brother or sister or a grown-up to help you. First, tie one end of the string to something big and heavy, like a chair or a table or a door. Now, put the other end of the string through the straw and tie that end of the string to something heavy too, so that the string makes a flat, straight line. Your rocket is almost finished. Now, blow up the balloon about halfway and pinch the end so the air doesn't escape. You might need someone else to help with this next part. Tape the balloon to the straw, like this. Now, prepare for launch. Are you ready? And blast off! So, what happened? Well, we just saw force in action. Forces are pushes and pulls, and they're what make things move. In this case, the air rushing out of the balloon pushed the straw forward, making it move. And this doesn't just work with rockets made out of straws. You can make a balloon-powered car, a boat, or even a balloon-powered airplane with the right materials. Now, try changing things up a little bit and see if your rocket behaves differently. Try blowing up the balloon even more next time. Do you think your rocket will go farther or not as far? Will it go faster or slower? Keep experimenting with your rocket and find out what you can discover about balloon power.
What a good rocket! Thanks for the idea, Squeaks. Hey, can I share an idea about what to do next? Could we make secret ink? I heard you and Jessie made some for National Coloring Day once, and I always thought it would be really fun. Awesome. Thanks, Squeaks. Let's see how it's done.
Squeaks and I are celebrating because guess what? On September 14th, it's National Coloring Day. National Coloring Day is just what it sounds like, a day to color and have fun. And that's exactly what we're going to do with a special project. We're going to make some invisible ink. That means the ink will disappear, and then you can color over it to reveal a secret message. All you'll need is baking soda, water, purple grape juice, a cup, and a few cotton swabs, like Q-tips. Oh, and a piece of white paper to write on, and a grown-up, of course. The first thing we'll do is mix 1/4 cup of baking soda and 1/4 cup of water. The measurements don't need to be exact, we're just trying to make sure we have about the same amount of each. This baking soda and water mixture will be our ink. Yep, that's all there is to it. Let's write something on this piece of paper here. I'm gonna come up with a secret message for you, Squeaks. Okay, now all we have to do is wait for it to dry and the message will be hidden. It looks like the ink is pretty much dry, so the secret message is ready to be revealed. The question is, are you ready, Squeaks? Let's do it then. This is what the grape juice is for. We'll take another Q-tip, dip it in the grape juice, and paint over the message. Check it out! Science is awesome! That's what the message is! There are lots of ways to make invisible ink at home, but this is one of the easiest, and I think the coolest, because we're doing the same thing lots of scientists do in their labs every day. No, Squeaks, they don't write secret messages, but they do mix things together to learn more about them, like we just did. The baking soda we use to make the invisible ink is really a type of chemical called a base. And when we added the grape juice to the base on the paper, they reacted to each other. That means they changed. When it touched the baking soda, a chemical in the grape juice changed to become darker. That's why the parts of the paper where the message was got darker, and we were able to read it. Now, baking soda is a safe chemical, so we can cook with it and use it for experiments at home, but scientists use it in their labs sometimes too. Actually, scientists use all kinds of bases in their labs, and sometimes they need to be able to test if a chemical is a base. To do that, they combine the chemical with something called an indicator. That's another chemical that scientists know will change color if it mixes with a base. And guess what? One of the ingredients in grape juice works as an indicator. It's called an anthocyanin, and it becomes a dark purple color when it touches a base. That's true, Squeaks. The grape juice is already purple, but when it touches a base like baking soda, it becomes much darker purple. So that's the scientific secret to our invisible ink. And now we can write all the secret messages to each other that we want, as long as we have grape juice on hand.
Squeaks just went into the other room to work on his secret message. But can I tell you a secret? On my secret note, I wrote that Squeaks is a great friend to do experiments with. I'll share it with him later. Oh, hey Squeaks. I wasn't talking about you at all. How did your secret message go? Awesome. I'm glad to hear it. How about we do one more? Which one do you want to finish up with? You want to show me how to make my own cartoons? That sounds amazing. Let's get started.
Oh, you're right, Squeaks. This is a classic. But did you know the best part of cartoons takes place inside your brain? Cartoons like this are made of a bunch of drawings. When you show those drawings one after another super fast, they look like they're really moving. That's called an animation. But the drawings aren't really alive or moving around. It's an illusion, a little trick that you can play on your brain. And today, Squeaks and I are going to make our very own version of this trick, called a zoetrope. If we spin all these drawings together really fast, they just look like a blur. That's why our zoetrope is going to have slits, which are little holes. We'll see each drawing through the slit and then see a black space after each one. It will be like we're seeing each drawing on its own, but super duper fast. And then when we spin the zoetrope, our brains will stop noticing the black space and connect the drawings together. The faster the zoetrope spins, the smoother the animation will be. You can make your own zoetrope along with us. All you need is some black construction paper, some white construction paper, scissors, tape, a ruler, 2 pencils, a round piece of cardboard or a paper plate about 25 centimeters or 10 inches across, and a grown-up to help because we'll be doing some measuring and cutting. For our base, we cut out this round piece of cardboard, although you can use a paper plate. We'll make a small hole in the middle, just big enough to push one of the pencils through and have the eraser catch on the top, but we won't put the pencil in yet. Next, we need to make the walls of the zoetrope. For that, we'll use the black and white paper. First, we'll cut 2 pieces of the black paper in half the long way, so we'll have 4 long strips. Then we'll take 3 of the strips and tape them together. Next, we'll wrap them around the outside of the cardboard base. We might need to trim a little off of the end to make sure it fits exactly. This is where we're going to put the slits to look through and see the animation. We'll cut 13 slits, each about 3 millimeters or 1/8 of an inch wide, into the top half of the black strip. We'll try to make them evenly spaced, about 4 centimeters or 1.5 inches apart. Just like we did with the black paper, we'll cut a piece of white paper in half so we have 2 long strips. We're going to take those 2 and cut them in half. That gives us 4 long strips of paper. We're going to take 3 of them and tape them all together. Our white strip is now half as tall as our black strip, and we're going to cut it so it's the same length. The white strip of paper will become the rectangles we use for each drawing. To make those rectangles, we'll use the ruler and one of the pencils to measure the strips into 13 rectangles that are each about 4 centimeters or 1.5 inches across. And now, it's time to draw. Our animation is going to be cyclical, which means that as soon as it's done, it's going to start over again from the beginning. So it's good to have an animation that
ends right back where it started, like a plane taking off and coming back down, or a person taking off their hat and putting it back on. We're gonna draw our friend Dino flapping his wings. Each of your frames should look a lot like the last one, with tiny changes from one to the next. See how his wings move up and down just a tiny bit each rectangle? That will help the animation look smoother. Once our drawings are done, we'll tape them to the bottom half of the black paper, with each rectangle right below one of the slits. And now we just need to tape the paper around the base, with the drawings on the inside. Now all we need is to make it spin. So we just stick this pencil through the hole we made in the base earlier, so the eraser catches on the frame and the pencil doesn't fall all the way through. Nice. You could also use chopsticks for this, or glue the hole in your base to a marble so that it can spin on a table. Or with some help from a grown-up, you might be able to use a record player or a spinning cake platform. And now we spin. Oh, cool. Check it out. If the drawings move fast enough, two illusions happen to make them into an animation. In between each frame, there's a blank spot where there's nothing to see. But when the drawings come quickly enough, one after the next, your brain stops noticing the blank spots in between. That's the first illusion. The effect of one picture on your eye lasts until the next one comes up. All your brain notices is the drawings. The second illusion is when your brain sees all those separate drawings and thinks that the pictures are moving. It fills in the blanks in between the frames for you and turns them into something that makes sense, like Dino flying, so you can just see the animation and enjoy the cartoon. Squeaks, we make an awesome animation team.
Wow, that was such a good activity to wrap up with. Thanks, Squeaks. How are you feeling? I'm so glad this helped cure your boredom. I had a lot of fun, and I hope you did too. Thanks so much for experimenting with Squeaks and me. If you want to keep learning with us and see any new experiments, you can hit the subscribe button, and we'll see you next time at the fort.